Practice test 2, chapter 6. I am going to work each problem by hand, and then I'm going to show you how to use the calculator. The first 5 problems all relate to the same information. The heights of fully grown sugar maple trees are normally distributed with a mean 95.5 feet and a standard deviation of 10.75 feet. Question 1. Find the probability that a sugar maple tree selected at random will be between 80 and 105 feet. So, this is a normal distribution. The variable x is height. And so this problem is coming from section 6.2. I am going to get out a blank normal distribution here and write down the given information. The given information is the average is 95.5 feet and the standard deviation is 10.75 feet. X is equal to height, and we are told that it's normal. Find the probability that a sugar maple tree selected at random will be between 80 and 105 feet tall. That, notation-wise, looks like this. So, picture. The mean of 95.5 is at the center, x-axis. 80 has to fall below the average, and 105 has to fall above. So we will shade the area between those two x values. To change from a problem in x to a problem in z, we must find the z-scores for each. So x is 80, z is x minus mu divided by sigma, 80 minus 95.5 divided by 10.75. And that is a negative 1.44. And that is rounded to 2 places accurately. And then x is equal to 105. Z is 105 minus 95.5 divided by 10.75. And that is a 0.88. So those are our 2 z-scores. Now we will draw the same picture above, but now we're in variable z. The mean of 0 takes the place of the mean of 95.5. In place of 80, we put its z-score of negative 1.44. And in place of 105, we put 0.88. And I'm still shading the area in between those 2 z-scores. The way the 2-page z-table works, I will look up both z-scores, and it will give the area below each z-score. So this would be the case using the 2-page z-table of the larger area minus the smaller area. So negative 1.44, there's a negative 1.4, and then a negative 0.04 up at the top. Your 2 fingers meet at 0.0749. 0.0749. And I'll write that in the picture. And then if you look up a z-score of positive 0.88, left finger on 0.8, right finger on 0.08, your 2 fingers meet at 0.8106 in the table. So that is the area below z equal to 0.88, 0.8106. So now that we have our 2 areas above and below, it's just simple subtraction. So the probability that x is between 80 and 105 feet tall is equal to 0.8106 minus 0.0749, which is 0.7357. And that would be the answer to number 1. And that would be letter B here. Calculator, with both versions of the calculator on the document camera. You would go to second variables, number 2, and with the older edition of the calculator, you will put in 80, 105, 95.5, 10.75 in that order, and press enter. 0.7369 by calculator. The new edition, you will put 80, 105, 95.5, 10.75, paste and enter. And you receive 0.7369 by calculator. And that is different from what we received by hand, but that is okay. You will notice that on the practice test I did not include 0.7369 as a possible choice. So letter B is the only possible answer. Number 2, if 150 trees are selected at random, how many will be between 80 and 105? So we are still in the situation with the sugar maple trees and their height, and we are still in section 6.2. This is the famous question of how many. And so this is actually a two-step process. With this particular problem, I will write down the question. The mean is 95.5. The standard deviation is 10.75. And we want to find X's height. And the question is, if 150 trees are selected at random, how many will be between 80 and 105 feet tall? If n equals 150 trees are selected, how many of the 150 trees will be between 80 and 105 feet tall? So this is the two-step process. The picture is still the same. 95.5 is at the center, 80 is here, and 105 is here. In part 1, or problem 1, what you would have to do is step 1, find the probability that a single maple tree selected at random is between 80 and 105. And we found that to be 0.7357. And so that was obtained from question number 1. Now step 2. If 150 trees are selected, how many will be between 80 and 105 feet tall? So that's where you take your 150 and multiply by the probability that a single maple tree selected at random will be between 80 and 105 feet tall. So sample size times the probability will give us the answer. And that turns out to be 110.355. Now let's explore the rounding here. Obviously, the rounding is rounded accurately to 110. So the answer is A, 110 trees for your answer. Letter A, 110 trees. Now, question 3. if a logger only wants to purchase the bottom 10% of trees, find the cutoff height. So we're still working with the same problem. Question number 3. We have our mean of 95.5 at the center, and the logger only wants to purchase the bottom 10% of trees. So we want to find the cutoff height. Find the cutoff height. So the picture for this one would be this. Again, the mean is 95.5. The standard deviation is 10.75. And the logger only wants the bottom 10%. To do this by hand, and this is section 6.2, we will need the cutoff formula, z times sigma plus mu. And so we need the z-score that signifies the bottom 10%. To do that, you would take the standard normal distribution and shade the bottom 10%, which is 0.1000. Obviously, that z-score is going to be negative, so we go into the table and try to find an area closest to 10% as possible. And that is here. 0.1003 is the closest. You will work your way out and up. Out goes to a negative 1.2, and up goes to a negative 0.08. So the z-score is a negative 1.28 if you look up the closest area to 10%, which is here. So the z-score, negative 1.28, marks the bottom 10%. Therefore, with the z-score formula, x is negative 1.28, excuse me, not the z-score formula, but the cutoff formula, times 10.75 plus 95.5. Negative 1.28 times 10.75 plus 95.5 is 81.74. So that's your cutoff. That signifies the bottom 10% of trees. And that answer is D. The way to do this in the calculator, and I'll just show the updated version of the calculator, is invert the norm. The area below the unknown x is 10%. You can put 0.1, 0.10, 0.1000. All of that's 10%. The mean is 95.5. The standard deviation is 10.75, and paste. And you have 81.72. So that is different from what we received by hand, 81.72. But this will not be an answer choice. The answer choice is 81.74, which is letter D. Number 4. Now suppose that samples of size 8 are taken to create a sampling distribution. Oh boy, we have a sampling distribution. Find the probability that a sample mean being at most 105 feet tall. So this new picture, or new problem, number 4, we still have the same information. The mean is 95.5. Standard deviation is 10.75. X is still height and continuous and said to be normal, but now we're taking samples, as many samples as possible, all of size 8, to create a sampling distribution. So N is 8. Remember, the mean of sample means is the population mean, and the standard error of the mean is the population standard deviation divided by the square root of the sample size. So your mean of sample means is located at the center and is still 95.5, and now we have an x-bar axis. Find the probability that a sample mean selected at random is at most 105 feet. That is the probability that a sample mean is at most 105. At most means less than or equal to. 105 is going to fall here, and at most means to shade below it, less than or equal to it. That area is the answer to the probability question. At most 105. So, X bar is 105, and we want to find its corresponding z-score. Here is the z-score formula in section 6.3. And that's going to be 105 minus 95.5 divided by the standard error of the mean, 10.75 divided by the square root of 8. And that z-score is equal to 2.50. And that's two places accurately. So the new picture in Z looks like this. 2.50 is here on the Z-axis, and I shade below. So the probability that a randomly selected sample mean is at most 105 is the same as the probability of a z-score being at most 2.5. So go to the z-table, and if you look up a z-score of 2.5, that is your answer, because that's the answer below it. And the answer is 0.9938 for problem number 4, 99.38%. So I'll write that down. According to the table, this is 0.9938. So up above, this area also is 0.9938. So the answer is C, 0.9938. With the calculator, you will go to second distribution, which is normal CDF, and press enter. And you will go from negative E99 on the X-bar axis all the way to a X-bar of 105. The mean is 95.5, but here for sigma, I have to put in 10.75 divided by the square root of 8, and then paste. Make sure you put in the standard error of the mean, not just sigma, but sigma over the square root of n. 0.9938. So the calculator and the table agree. 0.9938 is the answer. Now, question number 5. Same information. For the same sampling distribution created in 4, determine the unknown sample mean that falls at the 60th percentile. So, in this problem, number 5, the mean is still 95.5. The standard deviation of the original population is 10.75. X is still height, and it's continuous. We're still creating a sampling distribution by taking samples of size 8. And the mean of sample means is still 95.5, and then the standard error of the mean is 10.75 divided by the square root of 8. Here's the picture, X-bar axis, mean of sample means 95.5 at the center, and we have to find the unknown sample mean that falls at the 60th percentile. Remember, that means 60% below and 40% above. That unknown X-bar on the axis has to fall here for this to make sense. So all of that below is 60% and above is 40%. There's no way that the unknown X-bar can fall here, because area below it is never going to be as large as 60%. Remember, the area above the mean is always 50%, and the area below the mean is always 50%, and the total area under the curve is 1. So for something to be at the 60th percentile, it's going to have to be above the average. Now, if you're doing this by hand, you have to use Z times sigma over the square root of n plus mu. We don't know the z-score for this problem, but we do know our sigma is 10.75 and our sample sizes are 8 and our mean is 95.5. So the z-score is going to be the z-score that falls at the 60th percentile. So here's an unknown z, and it falls at the 60th percentile. So 60% of the area falls below it, and 40% of the area falls above it. So go to your z-table and look up an area of 0.6, or the area closest to it. And that is going to be, let's see, it looks like it's going to be 0.5987. And when you work your way out, you would have 0.2, and then up is 0.05. So 0.25 is the z-score there. 0.25. And I'm going to write that in the picture. 0.25. And then in the formula, the z-score is 0.25. That's the z-score that falls at the 60th percentile. 60% of the area is below it. And then when you plug into the formula, you have a cutoff of 96.45017474. And let's look at our options here. 96.45 is letter B. So they rounded to 2 places. Now the calculator is going to do this. Go to invert the norm, because it's a cutoff problem. The area below is 60%, 0.6 or 0.60. The mean is 95.5. The standard error of the mean is 10.75 divided by the square root of 8. And then paste. And then enter. 96.46 is what we have with the calculator. 96.46. Again, invert the norm looks like this for this particular problem, number 5. Standard error of the mean goes in for your sigma. Sigma over the square root of n, because it is a sampling distribution problem. 96.46. So that's problems 1 through 5, and they all pertain to the very same information about sugar maple trees. Let's start some other questions here. Change gears a little bit. Number 6. Give the name of the normal distribution that has the additional properties that the mean is always 0 and the standard deviation is 1. Hope you know that's B. It has to be the standard normal distribution in Z. Number 7, find the Z value to the right of the mean so that 54.78% of the area under the distribution curve lies to the left of it. So, we're going to draw the picture for this. We are in Z, so the mean is 0, Z-axis. Find the Z value to the right of the mean. That means it has to be here. That is to the right or above the mean. So that 54.78% of the area under the distribution curve lies to the left of it. So left of it. All of this is 54.78%. So find the unknown Z to the right of the mean such that 54.78% of the area under the curve lies to the left of it. So first we go right for the unknown Z, and then we shade below. So this is the picture for this problem. We will go to the 2-page Z table and look up an area of 0.5478. And this is exactly how the 2-page Z table works. 0.5478 is here exactly in the table. Work your way out to 0.1 and up to 0.02. That Z-score is a positive 0.12. Final answer. So Z is a positive 0.12. There's your z-score. And on the calculator, it would be as easy as second distribution, normal CDF. And you would go, actually, second distribution, invert the norm. The area below, invert the norm, number 3. Finally. Okay, something's happening here. Let me just clear that out. Second variables, number 3. Okay. The area below is 0.5478, and then we're in Z, so the mean is 0 and the standard deviation is 1. So paste. 0.12 to 2 places is your Z-score. So the table and the calculator agree. And that answer is B. So 7, letter B. Number 8, find the probability that a Z selected at random is between 1.12 and 1.43. For this problem, I will draw my mean of 0, 1.12, and 1.43 Z-axis, and shade between. And this is going to be, again, the case where I find the area below 1.12 and the area below 1.43. So look up both the Z-scores. 1.12 gives an area of 0.8686. Sorry. And 1.43 gives an area of 0.9236. And that's the larger area. So, the probability that a Z-score is between 1.12 and 1.43 on the Z-axis is 0.9236, the larger area, minus 0.8686, the smaller area. And that difference is 0.0550, and that's also your answer. Calculator, you will go to second variables, normal CDF, 1.12 to 1.43. And then the mean is 0 and the standard deviation is 1, and then paste. Smaller Z, larger Z from left to right. And you get 0.05499, which is 0.0550 if you round to 4 places accurately. So the table and the calculator agree. And the final answer is D, 0.0550. Now we're getting into some more complicated word problems. The average age of Amtrak passenger train cars is 19.4 years. If the distribution of ages is normal and 20% of the cars are older than 22.8 years, find the standard deviation. Oh, this sounds like an algebra problem. So the average age of Amtrak passenger train cars is 19.4. I'm going to write that down. This is a distribution of ages, and age is normal. 20% of the cars are older than 22.8 years. Find the standard deviation. So I'm going to write this down. The mean is 19.4 years. And we have to find the standard deviation. And so let me draw the picture, what we have so far. 19.4 is at the center, and X is age. It says 20% of the cars are older than 22.8 years. 22.8 should fall here. And 20% of the cars are older than 22.8 years. So basically, the probability that X is above 22.8 is 0.2000. That's what they've given us. They've given us the average, and they've given us this probability by saying that 20% of the cars are older than 22.8 years. So that's going to be above 22.8. Find sigma. To find the standard deviation, we have to use the z-score formula and cross-multiply to solve for the sigma. We need to find the z-score that's represented here in this picture. The z-score that represents the 22.8 is here, and it cuts off the upper 20% just like this picture. So if it has 20% above, it has 80% below. And with the two-page z-table, we look up an area of 80, and that area is closest to 0.7995. When you work your way out to 0.8 and up to 0.04, the z-score that cuts off the upper 20% is 0.84. So I'm going to write that down, 0.84. So 0.84 is equal to 22.8 minus 19.4 divided by sigma. We would cross multiply, and we have 0.84 times sigma equals 1 times 22.8 minus 19.4. That difference, 22.8 minus 19.4, is 3.4. So 0.84 times sigma equals 3.4. Divide both sides by 0.84 to solve for sigma. And that gives you a standard deviation of 4.04761948. And the mean's given to the nearest tenth, so they're probably going to say that it's 4.0 for the final answer for the standard deviation. Remember, if you don't want to use the z-table to find this z-score, you could put in, invert the norm, 0.8. This is the older edition of the calculator. And you get 0.84 for your z-score. With the new edition, you would do invert the norm, 0.8, mean is 0, standard deviation is 1, and paste. 0.84 is the z-score. But if you use the table, you have to look up 0.8 as an area there, 80% below it, to get the 0.84 z-score. So the answer to this question is letter C. Looks like they rounded to two places. So 4.05 here. So letter C. Number 10. The average teacher salary in North Carolina is $35,441. Assume a normal distribution with a standard deviation of 5,100. For a sample of 75 teachers, what is the probability that the sample mean is greater than 36,000? This is a sampling distribution problem, and I'm going to write down what's given. This is kind of like one we did in class from the textbook. $35,441 with a standard deviation of $5,100. So this is teacher salary. Assume the distribution is normal. For a sample of 75 teachers, what is the probability that a sample mean selected at random is greater than 36,000? So that's going to look like this. X bar is greater than $36,000. A sample mean. It didn't say what's the probability that an individual salary is greater than 36,000. They said sample mean, so that's X bar. You will draw in your mean of sample means, and that's 35,441. 36,000 falls above it, so we want to shade everything above or greater than 36,000. That area is the answer to the question. The z-score for $36,000 would be the next step, and that's X bar minus mu over sigma over the square root of n. So 36,000 minus 35,441 divided by 5,100 over the square root of 75. And we will round that to two places. And that's 0.95 as a z-score. So the distribution in z, which is very much the same picture as above, 0.95 and shade above it. When we look up a z-score of 0.95 in the two-page z-table, the area below it is going to be 0.8289. 0.95 gives an area of 0.8289 below it. 0.8289. So the area above it in both of these pictures is 1 minus 0.8289. Final answer. And that is 0.1711 as the answer to the probability question. So about 17%. And that answer is B here, 0.1711. In the calculator, you would go to normal CDF. You would put in 36,000 for the lower X bar, positive E99 for positive infinity, 35,401, and then standard error of the mean, 5,100 divided by the square root of 75, and then paste. And you have 0.1713, which is a little bit different from the table, but not much. This will not be as an answer choice A, B, C, D. As you can see, it's not an answer choice here, 0.1713, only 0.1711. Number 11, moving right along, and that would be the last page of the practice test. What is the term that gives the number of standard deviations that a data value x falls above or below the mean, or is equal to the mean? And that is a z-value or a z-score, letter C. That particular term was on the first test. So number 11, C. Number 12, on a 100-point exam with grades normally distributed, the mean grade is 70 and the standard deviation is 10. If students are graded on a curve, find the cutoff score of those receiving A's. Note the top 5% of students will receive an A. This is from section 6.2. The mean is 70, the standard deviation is 10, and we would like the score that cuts off the top 5%. So I'm going to write this down. The mean is 70, the standard deviation is 10, and we would like to denote A's in the class. Class average is 70. The top 5% would be the A's. X-axis is test scores. And I want to find this X here on the axis that denotes the top 5%, which is 0.05. And then that means that this is 0.5 and this is 0.45 because 95% of the area is below it if there's 5% above that unknown X. To do this one by hand, you have to use the cutoff formula. And so Z times 10 plus 70. This is kind of a tricky situation. If you work this same problem in Z, you would have your Z-axis, bell-shaped curve mean of 0, shade the top 5%, which is 0.05, and you're looking for this unknown Z. It's 1.65. Because you have to look up the area of 0.95 in the Z table, and we talked about this situation several times. 0.95 falls halfway between these two areas. So the textbook says go with the z-score that gives the larger absolute value, and that's 1.65. The calculator gives you 1.64. Be careful. So 1.65 goes here. That's also the z-score that falls at the 95th percentile. 95% below, 5% above. 1.65 times 10 plus 70 will give you 86.5. So that's a B. So the people that have 86.5 and above make A's in the class, the top 5%. And that answer is A. In the calculator, you will have to go to invert the norm. The area below the unknown x is 95%. The mean is 70 and the standard deviation is 10, and then you paste. 86.4 with the calculator. Let's see if that can be tricky. And I may not have been tricky here. I don't even have an 86.4. Look how nice. 86.5. But the calculator gives 86.4. Problem number 13. Find two z-scores that bound the middle 40% of the standard normal distribution. Okay, this is a basic problem. Bound the middle 40%. So this is 0.40 or 40%. By symmetry, this is 0.2 and this is 0.2. The right tail is 0.3 and the left tail is 0.3. 0.3 plus 0.2 is 0.5. So by property, I have 5% above and 5% below the mean of 0, and the total area under the curve is 1. So I'm looking for this negative z and this positive z. The way the two-page z table works is I will look up the area below those unknown z's. So I'm either going to look up an area of 0.3 or an area of 0.7. The area below the negative z is 0.3. The area below the positive z is area of 70% because there's 30% above it. I'm going to look up the negative z by going in and finding a 30% area. And the closest to 30% area looks like it is, let me see here, .2981 may be the closest. Let me enlarge that. Again, if you ever doubt that, you could do a little bit of subtraction. 0.3015 minus 0.3 is 0.0015. And then 0.3 minus 0.2981 is 0.0019. Let me show you that. So the closest one is actually 0.3015. Initially, I thought it was 0.2981. So the closest area to 30% is 0.3015. So here we are. And when you work your way out and up, it's a negative 0.52. Negative 0.52 for your z-score. Out and up, negative 0.52. So let me write that here. So this z-score, they're going to be plus and minus 0.52 for your final answers. So this one's a negative 0.52 and this one is a positive 0.52 by symmetry. So the answer is A. With the calculator, you would just do invert the norm. 0.3, mean is 0, standard deviation is 1. If you're just in Z, and you get negative 0.52. You could also do the 70% area, 0.7, paste, positive 0.52. So plus and minus 0.52 would be your answer. Question 14. It says, if x is a normal random variable with a mean of 6 and a standard deviation of 3, find the x such that the probability that x is greater than x is equal to 0.7054 as shown below. Note the diagram is not necessarily drawn to scale. So let's write this down. X is normal. The mean is 6. The standard deviation is 3. Find the value of x on the x-axis such that this is a true probability statement. Okay? So here we go. The mean is 6. The standard deviation is 3. 3.0. And at the center, we have the mean of 6, and it is x. And the other information they give us is the probability that capital X greater than lowercase x is a probability of 0.7054. They also give you a picture. That x, even if I didn't give you the picture, you should know that unknown x has to be below the mean. So the unknown x we're looking for, that probability of 0.7 is so large, all of this area above it is 0.7054. So we have to find this x such that the probability that x greater than lowercase x here is about a 70% chance. What is this cutoff here is what they're asking. To do this by hand, you need the z-score formula, and I said that wrong, the cutoff formula. The standard deviation is 3, and the average is 6. And that's a 6 there, not sigma. But we don't know the z-score. And the z-score for that unknown x obviously is going to be negative. So we have our z-axis, our bell-shaped curve, our mean of 0, our negative z. And this area is 0.7054. So we're trying to find the unknown z for this unknown x. The area that we look up is the area below it, and that's 0.2946. 1 minus 0.7054 is 0.2946. So I'm going to look up 0.2946 and find the area closest to it, and it's actually exactly here. A negative 0.54 is the z-score. Negative 0.54 if you work your way out and up. So negative 0.54 is here, and it also goes in the formula. So the z-score for this unknown x here is negative 0.54. And then plugging into the formula, you get 4.38 for your cutoff. And that makes sense. 4.38 should be smaller than 6. So there's your cutoff. Now it's a true statement. The probability that a randomly selected x greater than an x of 4.38 will be about 70%. 0.7054. Now we know this x, 4.38. On the calculator, you will have to invert the norm. The area below the unknown x is 1 minus 0.7054. The mean is 6 and the standard deviation is 3. And this is in x. We never have to go to z. Paste and enter. 4.38 is that x value. And it's the same as with the formula, the cutoff formula. Final question is not even a problem that we have to work. Suppose that a random variable x has a normal distribution with a mean of 16 and a standard deviation of 3. Approximately what percentage of values will lie between 13 and 19? The answer is 68%. What I intended for you to do here is to kind of draw a picture. The mean is 16, the standard deviation is 3. So here we go. And then mu plus sigma, mu plus 2 sigma, mu minus sigma, and mu minus 2 sigma. So 1 standard deviation above is going to be 19. 2 standard deviations above, so you add 3 each time. (22). 1 standard deviation below is 13, and 2 standard deviations below is 10. And the empirical rule says that within 1 standard deviation of the mean, here, 13 and 19, we are guaranteed 68% of the data in this particular data set. So I really wanted you to kind of work the problem that way. There may be other ways to work that same problem, but if you have a distribution with a mean of 16 and a standard deviation of 3, this is what the numbers would look like on the axis. 1 standard deviation below would be 13, 1 standard deviation above would be 19, and we're guaranteed 68%. So what percent of values fall between 13 and 19? 68% by the empirical rule. Well, that concludes the practice test. I hope that the practice test has been helpful, and let me know if you have any more questions whatsoever. I only plan to make the practice test a integrity video. Make sure, again, you know how to work every single problem, know your rules, your definitions, your properties of a normal distribution, and understand how to either use the 2-page z-table or how to use the TI-84. Those are 2 different methods, and they are going to work different from each other, but at the same time, regardless of method, you receive the correct answers to the problems. Hope you have a blessed day. Let me know if you have found this practice test to be beneficial. Thank you. God bless you.